Hi, my name is Donnie, and today we are going to see what kind of data and graphical display exist, along with the benefits each graphical display conveys. Data is originally very unorganized and hard to read, since it is just a barrage of numbers or sometimes words. To make data legible, we use graphical display depending on different situations. We are going to see why do people display data in various ways today. The reason why people display data in various ways is because people gather different types of data for different reasons, and each data has their own best ways to display its data by using its features. Before we see what types of different graphical display exist, we need to know the difference between the quantitative data and the qualitative data. A quantitative data are the ones that shows the number proportion of variables between certain intervals. Histograms are a good example of it. We see in each certain interval how many variables are included between those. Categorical data, meanwhile, is a data categorized as a different individual belongs. Usually it is known as data gathered by words. That is, for example, answering a question such as, "What is your favorite color?" It would be either red or blue or any kinds of color that are no numbers for sure. But just because the value or the data is a numerical value doesn't mean that it is necessarily quantitative. So here, let's assume that we have made a survey to students what their favorite snack is, with 5 different possible categories: ice cream, gummy bear, chocolate chip candy, and gum. And let's see how it would look like when we make the survey data into a bar chart. The benefit of the bar chart is that it can display relative numbers or proportions of multiple categories, and it can visually summarize a large set of numbers. Here we had approximately 40 students, which is quite a big number. And also is very easy to read, and it is one of the most generally used graphical display. Dot plots are very somewhat similar to bar charts, but different in some ways. First of all, it is used for relatively small sets of data. Meanwhile, bar charts can be used for large sets of data as well. This is because dot plots do not show the frequency points, while the bar charts do show the frequency points on the vertical side, if you see here. Next, dot plots clearly display the outlier. And dot plots do not need the frequency points, which I just mentioned. It can be an advantage, but it can be a disadvantage at the same time. Lastly, it can be used with both quantitative and numerical data. If we made it into a pie chart, then it would look something like this. Pie chart can summarize a large set of data easily, and it displays relative proportion of each value or data easily. As you can see here, it shows the percentile of how many people from the proportion of 40 people wanted each category. Ice cream, 30% wanted, for example. And it can be interpreted without confusion, and it is very simple. Next, assuming we have done a survey in a class with 20 students, what their height is, let's see how it would look like when we change that data into a histogram. Histogram is a graphical display which is very easy to compare data, and it is used with wide range of information, and is especially helpful with large set of data because it is quite simple and it visually aids the audience in various ways, so it is very convenient for the viewers to read the graph easily. In fact, about histogram is that you can make exactly the same graph but with a relative frequency. A relative frequency is frequencies divided by the total number in their population. So for example, here in the interval 104 centimeters to 150 centimeters, here you see the number of variables here was 2. So 2 divided by 20, the total number of students is 0.1. So what happens here is that the vertical 2 becomes 0.1, and here between 150 and 160, the relative frequency is 0.35. The number here will be 0.35. So about here will be 0.3 and 0.4. So even though you use the relative frequency on the vertical axis as a units or the frequencies, it is exactly the same graph. This is another interesting fact about histogram. Lastly, stem plots. First of all, stem plots are called as stem plots because the y values, the intervals here, you can see the different categories are called as stems, while each data inside its interval are called as leaves. Therefore, it is also called as stem and leaf display. Stem plots are useful for giving a quick overview of the distribution of the data, and it conveys much more accurate form of data than the histogram. While histogram counts every data between its interval as how many exist. For example, between 140 and 150, only 2 exist. But we don't know if it's 144, if the data is 145.7 or something like that. But stem plots show every accurate form of each data. For example, here we see that between 140, there's 141 as one value, 142, 148, and 148. This is the difference between the stem plots and the histogram.